In this video, I want to go through another example of curve sketching with asymptotes. So we've got y equals x over x squared minus 1. So again, the first thing I'm going to look for is the domain or any restrictions we have. So in this one, we don't have any square root signs, and our denominator, we don't want our denominator to be equal to 0, but in this case, it's not possible because x squared is always going to be either 0 or positive, and then we're just adding 1. So our domain for this one will be all real x. So there is no restrictions on the domain. Then I'm going to have a look at symmetry. So I'm going to find f of minus x. So in our case, that would give us minus x over minus x squared plus 1, which is equivalent. I'm going to pull this minus just out the front of that fraction. So I'd have x over, and we know that minus x squared is just equivalent to x squared plus 1. So that means that this is the same as negative the original function, so minus f of x. And because of that, it means it has odd symmetry. So that's going to help us sketch it in a minute. All right, the next thing I want to have a look at is intercepts. So I'm going to set y equal to 0 to find my x-intercepts. So I'm going to have 0 equals x over x squared plus 1. The only way that can happen is if the numerator is equal to 0, so it would be x equal to 0. If you want to go through, you can do the y-intercepts as well by setting x equal to 0. We already know it's going to pass through 0, 0, but you can do this process just to double check that there's not another intercept somewhere. And we end up with 0 over 0 squared plus 1, which is just 0. So we know it's going to pass through the point 0, 0. So now that we have a particular point, I'm going to draw up my axes and mark that on. Okay, so I'm just going to mark the origin there. We know our curve has to pass through that point. Now I'm going to have a look at my limits as x approaches infinity and minus infinity. So the limit as x approaches infinity of x over x squared plus 1. To find that, I'm going to divide everything in there by x squared. So I'd have the limit as x approaches infinity of 1 on x over 1 plus 1 on x squared. And as we take the limit as x approaches infinity, this is going to go to 0 and this one's going to go to 0. So that's going to give me 0. So my function is approaching 0, but we need to know whether it's coming from above or below. So that's when we have to have a look at what's happening here. If we're substituting in really, really big positive numbers, this will still give me a positive number in the numerator. And because we're squaring it, it's going to give us a positive in the denominator as well, and we're adding 1. So that is going to give me positive. So we're going to approach 0 from above. It's like we have an asymptote along here at the end. Again, we do pass through this line here, through the x-axis down here, but it's like we're going to approach an asymptote at the end. Now I'm going to have a look at what happens as we approach negative infinity. And we've still got that same function. So we've got the limit as x approaches negative infinity of 1 on x over 1 minus 1 on x squared, which will again just give us 0. But this time, because we're substituting in really, really big negative numbers, the numerator would be negative. Oh, hang on, that's a plus as well. The numerator would be negative, but the denominator is still going to be positive because of that squared. So overall, that's going to give us a negative. So we're going to approach 0 from below. That means we're going to come up this direction. And it's like there's an asymptote at the end there as well. So we know we have to be approaching this direction and approaching this direction, but we also have to pass through 0. So what that's going to mean is that we're going to have to come down and then sweep back up, and then it's going to come up here and sweep back down to 0 again, or towards 0. So we know that it's going to have a turning point somewhere in there. So this is where I'm going to start using calculus. So we're going to find our maximum and minimum points to determine sort of how far down that curve's going to come and how far up on this side. So to differentiate this, I'm going to use the quotient rule. So my u is going to be the numerator and my v is going to be the denominator, x squared plus 1. So I'll differentiate both of those. Give me 2x there. And then my derivative is going to be v u dash, so x squared plus 1, minus u v dash, so 2x squared, all over v squared, so x squared plus 1 all squared. Now if we simplify that, we'll get minus x squared plus 1 over x squared plus 1 squared, and that's going to be equal to 0 when we're finding the stationary points. Now, the only way that a fraction can be equal to 0 is if the numerator is equal to 0. So we're going to have minus x squared plus 1 is equal to 0, which means that x squared is equal to 1, or x is equal to plus or minus 1. So we know that they're the x coordinates of our stationary points, then we want to find the y coordinates. So at x is equal to 1, then y would be equal to, and we're going to substitute 1 in here, and that would give us a 0.5 or a half. Now remember earlier we figured out that our function was an odd function, so it has that rotational symmetry. So that makes sense with our our stationary points being at 1 and minus 1. And it also means that this is going to be at minus 0.5 because it has to have that symmetry. So that means our curve is going to come down to here and up to here. So then we can draw in our curve. It's going to come up and then it's going to come back down and approach 0 as we go along this side. So we can rub out that arrow I drew as a guide before. And then it's going to come back down this way and back up towards 0 from below. Now let's have a look at what that actually looks like when you use graphing software. So you can see that curve that we got correct, and we've got our maximum and our minimum points there. So that's the second example of looking at curve sketching with asymptotes.